We are going to look at a problem from the classwork covering sections 1.4 through 1.6. We are going to look at question 9, which asks us to solve the equation by completing the square. We begin with our equation, 6x squared minus 6x minus 1 set equal to 0. This is our quadratic equation in standard form, where we have ax squared plus bx plus c equal to 0. Our first step in our process to complete the square is going to be to move our c, or our constant term, to the other side so that we have our ax squared, our bx on one side with c on the other. So for our equation, I'm going to add 1 to both sides to move my constant, which is the 1. That will leave me with 6x squared minus 6x on the left and 1 on the right. My next step, and this step only needs to happen if the leading coefficient, or our a with our x squared, that coefficient on x squared, if that's not equal to 1, we want to divide all terms by a in order to make our coefficient on our x squared term 1. As our coefficient is 6, we will divide all 3 terms by 6, which will give me x squared minus x equal to 1/6 on the right. All right, so we are now in the form we want, and we can begin the process of identifying the value that we need to add to our x squared and our x term in order to create a perfect square trinomial. There is a process you can do to find this, and it's the same process each time. We're going to start by taking b. That's the coefficient on our x. So if we take the b, in this case, b is equal to -1. If we take b and divide it by 2 and square that, we have -1 over 2, or -1/2. We will square it, which will give us a positive 1/4. We are always going to be adding our value when we add it to both sides, because when we square a positive or negative, we're always going to get out a positive value. So we will add 1/4, and we want to add it to both sides to maintain the truth of our equation. So we now have x squared minus x plus 1/4. This is an equation, or an expression, quadratic, that is in perfect, it is a perfect square trinomial. So what we can do is we can now express this in its factored form, and a perfect square trinomial has the same 2 binomial factors. We can write it as those factors, x, and because our b was negative, it's minus. And in order to find the second term, you really can just look right here. Your b over 2 is always going to tell you what value you need, and you will square it. So x minus 1/2 squared, if you were to expand and multiply, you would find it's equal to x squared minus x plus 1/4. On the right side, first I'll put my equality. I'm going to take my 2 fractions, my 1/6 plus my 1/4, and I'm going to add them together and simplify. That's going to leave me with 10 over 24. Now my fraction's not in its simplest form, so I will reduce, which will leave me with 5 over 12. And on the left side, I still have my 2 binomial factors written in that squared form. Okay, so this method is now going to use the square root property, where we have a square root equal to a value on the right, or a constant, and we can take the square root to cancel out our square on the left. On the right, we're going to take the square root as well, but we're going to consider the fact that it could have been positive or negative, and we'll show that by taking the square root and including the positive and negative signs there in front of our radical sign. Simplifying on the left, we will have x minus 1/2, and on the right, it's going to be plus or minus. Now our radical square root of 5/12 can be split into square root of 5 over square root of 12. We will simplify, I lost my work. We will simplify the radical of 12 so that we have plus or minus square root of 5. And square root of 12, it's 4 times 3. That can be written as 2 radical 3. On the left, I'm going to bring down my x minus 1/2. I can go ahead, I'm going to draw a little line here to separate that. This radical 3 in the bottom, the square root, we do want to go ahead and remove the radical from our denominator. And we do that by multiplying top and bottom by the square root of 3. On the top, that's going to give me square root of 15. On the bottom, my 2 square root of 3's, when I multiply them, will give me a 3. And we are still going to multiply that by the 2 that we had originally. So altogether, when I finish that, it will give me the product of 6. So I'll have plus or minus the square root of 15 over 6. On the left, I still have my x minus 1/2. I will finish my problem by moving the 1/2 to the right, adding 1/2 to both sides. And I'll have x is equal to 1/2 plus or minus the square root of 15 over 6. Now, I believe you can put this in the computer exactly in that form. But if you would like to go ahead and simplify it a little further, if you were to follow a different process, you wouldn't have it necessarily in that form. What I'm going to do, I'll bring it down first so that you can leave that box up there. I'm going to recognize that 6 is going to be the LCD for these two fractions that I have. So I'm going to express my first fraction as an equivalent fraction over 6. That's going to give me 3 plus or minus. I have my square root of 15. And on the bottom, I now have 6. So if I wanted to write it as one fraction, I could go ahead and write it and express it in that form. Really, I believe either answer should be accepted on the computer, but I just wanted you to see both of them.